Hello everyone, welcome to the third video. I will try to keep it very short because I was in a session yesterday where students from different verticals, especially from engineering background, were there, and then a few of the students who watched the couple of videos that we did till yesterday. So they were asking about a question. So how is it relevant to us, right? Though I have uh, briefly explained in my initial video, but there were a few questions that came. So I just thought of giving a brief relevance to them. So maybe there are a few questions, right? So if I'm an engineer or civil engineer, if I'm from electrical and electronics engineering, what is it for me? Something like that. So now let us try to simplify things. So if you are a civil engineer, you might be thinking quantum computing is not for me, which is perfectly fine. So if you are a mechanical engineer, you might feel, right, ideally this sounds like computer science and not for me. And EC background, when I meant EC, electrical and electronics engineering, they might think this is for researchers and then from practitioners or whatever. So, I mean, what generally I sensed is that this is not for the core domain guys, but this is for somebody who is already relevant to the who is already working or exploring computer science related engineering, right? So that's what it is. So now, all these thoughts are understandable. I'm quite okay because, but they are based on wrong assumption. So let me tell you this upfront because assumptions are always assumptions, right? So they come with our understanding, but we need to set them straight. The idea when we started doing this uh, uh, video series is that we wanted to simplify things. Now, if you see on the screen that I just typed one of the question, and then what do engineers actually do, right? So, and then just reflect for uh, 2 3 minutes or at least for few seconds on this one so that you will be able to relate to what I'm actually talking about. So once you are an engineer, once you are out of the college or academia, what do you do? So if you are a civil engineer, you might go design a bridge, right? So if you get an opportunity, or you might want to optimize a supply chain problem that you get, or you may be managing a power grid or improving an engine that is already existing, right? So these are the possibilities, few possibilities. But you are dealing with complex systems, not isolated formulas, right? So we all learn theory, but when you mix theory with application, so then only it will be helpful, right? So this is what. Now, having understood this, so what is it that we are just if you take a step back and understand why quantum computing exists because of complexity alone, right? We said there is a certain struggle that classical systems go through. So that's where when complexity increases, your quantum computing relevance increases, right? So this makes it relevant for any engineering graduate, irrespective of branch or discipline, right? So now I would go and say, basically, for your understanding, as a takeaway summary of this slide. So, I mean, if you think engineering as a discipline and not as a branch, then everything will become relevant to you now, right? So think on it, reflect on it for a second, so you will understand what I meant. So now let us get on to this simple real world problem that we spoke about, but I will just touch base on it as a recap for 1 minute now, right? So now you have materials, cost constraints, time constraints. These are different variables, right? If one variable changes, it will have a impact on the other ones. Suppose suddenly you have a cyclone or an impact on environmental factor, so your other materials reaching you might get impacted. Cost will shoot up. There is every possibility. Time will shift from left to right. and then safety rules, so that also you might have to view it in a different scale. So now what happens here? If one option changes, so you will have to check option one, and then see, trying if you wanted to check the best one, right? First, you will check linearly option one, option two, option three, check, compare between one, two, three, and then say, I will pick this one and then go. But now, instead, if you see the right, so now classical thinking is linearity one, two, three, and then you will pick about the whichever option is suitable for you or relevant, best one, right? So now, if you think of a quantum thinking, so if you explore all the many possibilities that are available or that are possible together at once, right? So then that is quantum thinking, right? Let's simplify. So now these are the things that you do, but I will let you read these slides, taking a pause on the video. But what I would want here is that there are two, three key important takeaways from this slide. So whenever large interconnected variables are involved, so that is where I think quantum computing relevance increases. So today, I think most of the simulations end up with approximations, but what is more important is that, simulation plus optimization, whenever we do it with certain kind of realistically, so then that's where the quantum computing relevance increases, right? So that's the takeaway of this slide. So now if you think from your branch aspect or discipline aspect, so then this is what you will be able to relate, right? So now, as a future engineer, once you are out of the college, what is it that I need to probably understand? This is more important, right? See, technology cycles are becoming shorter these days. The execution cycles are becoming very, very faster. And the other important aspect is that uh, if you see on the left and right, two things I have written. Memorizing things or memorizing tools doesn't have any importance these days. According to me, I think I have read somewhere that there are 1500 to 1800 tools that are available. But how many will you be able to just uh, get a hold of, right? So you should think from a model aspect, and then chasing the trends will not help you. So there is a clear difference between fad versus fashion. Fad is something temporary. Today it might come, tomorrow it might disappear. But fashion is something like a trend, it will go on. Reflect on it also for some time. So now in this series of videos, what I urge you to do is that you understand and then set the fundamentals right. So once you understand the fundamentals, then next step is that what happens? Your adaptation becomes very, very easy relatively, and then your thinking will have a decent shift, right? So this is all it is about. So we are not replacing anything, we are just extending our understanding so that we might be able to handle complex problems little better, right? So this is what about it is. Now, this is one of the important slide that I will talk about, which is very important, and then help you eventually, right? So now asking the right questions is more important. So if you ask or if you think that if it is in only in my syllabus or if it is giving any credits, so then only I will take it up. So then probably it's not the right kind of an approach that I would say. So instead, if you think of complexity, of optimizations, of models to systems, so then you are shifting your mindset slowly towards quantum thinking, right? So today you may not be able to directly solve something via this mental shift, but slowly and steadily, if you approach this way, probably the advantage is that you will not feel competition, you will stay ahead of the competition and then many of the peers in your industry as well, and it will slightly give you an edge, right? So that is what it is. So classical methods have always limits, and what we are trying to do here is that we are trying to make ourselves quantum ready, right? Let us call it that way. So now with this, thank you very much for patiently listening to this. And then as we go ahead, the series become very, very interesting. So if you wanted to connect beyond this lecture or this video, so this is my LinkedIn. You can scan and then message me, and then maybe with a little disclaimer that I will not be able to immediately reply you, though my messages are open. But as soon as I see it, I will try to reply with relevance. Right? So thank you very much. If you need anything more that you wanted me to add, um, you are free to tell on my LinkedIn messages, because that's where most of the times I will stay connected and then check professionally. Thank you very much once again. We will meet in the next video very soon. Thank you.